Okay, in this lecture video, we're going to talk about how we can describe how concentrated or how dilute a solution is quantitatively. So telling us a solution is concentrated or dilute is a qualitative way to describe how much solute is dissolved in the solvent. But we want to be quantitative about our work, so we're going to look at how we talk about concentration quantitatively with a number and a unit. Now, chemists and scientists do this lots of different ways, but the most standard way is using something called molarity. Now, molarity is defined as the moles of solute per liter of total solution. So what we're talking about here is, in this particular picture example I'm showing you, is we've got a volumetric flask. It's a special piece of glassware that allows us to measure out a specific volume of liquid. And what we've done is we've added some weighed out amount of solute. It could be anything. And then what we do is we add some water because we're making an aqueous solution. So we add a little bit till we dissolve our solute. So at this point, we kind of shake it up, get the solid to dissolve. And then we add more water until we have added enough water that the meniscus is on that line. And at that particular point, we will know the exact volume of liquid that we've added because this entire flask is set up to hold a specific volume. So we know how much solute we've weighed out, and we know how much volume of solution we have, which means we could calculate a molarity because we've learned how to convert between the mass of a weighed solute and the moles of actual molecule that we've weighed out, and we know the volume that we've dissolved it in. So we're going to do a whole bunch of examples to feel for how that works. So the molecule that we're going to use in our example studies here is called thujone, because I have to pick some molecule to work with. And this is the molecule out of the movie Moulin Rouge. So if you've seen that movie, at the very beginning, all the bohemians are drinking this green liquor called absinthe. And inside that liqueur is a molecule from wormwood oil called thujone, and that's what's responsible for all the hallucinogenic properties. If you have not seen that movie, it's quite good. But the chemical formula for thujone is C10H16O. And if you were to add up the molar masses of all of the atoms present in a mole of this molecule, you would get that it has a molar mass of 152.23 grams per mole. Okay, so that's what's going to allow us to make the relationship between the mass that we weigh out in lab and how many moles of actual molecules are on the scale. So let's do some example calculations. So in our first example, let's say, I don't want to write in blue, let's say that we have 720, and I'm going to put a decimal point there so I can keep track of my sig figs, 720 milligrams of thujone, and we dissolve it in 43.5 milliliters of solution. So our total volume of solution is 43.5 mils. So we want to know what is the molarity, or big M, of this solution. And molarity has units of moles of solute per liter of solution. So let's calculate the moles first. So we've got 720 mgs of our compound. We know that the molar mass of thujone, I gave that to you already, is 152.23 grams per mole. So I can't be in milligrams for my calculation. I need to be in grams. But I know that there is 1 gram for every 1,000 milligrams. My milligrams cancels out, leaving me with units of grams. And I know that I will have 1 mole of thujone for every 152.23 grams that I weighed out in lab. Again, grams cancels out, leaving me with units of moles. So if I finish doing that math, I get, I need a spot to write it here, 4.73 times 10 to the minus 3 moles of thujone. That's our solute. So that's the top part here in our molarity equation. Now we know that we need to get the bottom part, which is liters of solution, and I know how many milliliters of solution that I have. So I can take my 43.5 mLs, and I know that there is 1,000 milliliters in every liter. My milliliters cancels out, telling me that my solution volume is 4.35 times 10 to the minus 2 liters. So then if I want to calculate the molarity now, I take the moles that I first calculated. So that was 4.73 times 10 to the minus 3 moles. And I divide it by my volume, which was 4.35 times 10 to the minus 2 liters. And if I do that math, I get that my solution has a concentration of 0.109 moles of thujone for every liter of solution that I have. We also call that 0.109 molar solution. So anytime you see a big M, it is the same thing as moles per liter. So let's do another example then. In this example, let's say that I have 10 mils of a 0.109 molar solution of thujone, and I want to know in that 10 mils, how many moles of thujone molecules do I have? So you could solve this problem lots of different ways. Whenever I see molarity, I like to rewrite it. So I know that I have a 0.109 moles of thujone per liter solution, and I know that the volume of solution that I have is 10.0 milliliters. Or if I wanted to convert that to liters, would divide it by 1,000, and I know that's 0.0100 liters of solution. So if I want to know how many moles of thujone are in this particular volume, I would take my volume of solution, which is 0.0100 liters, and multiply it by the molarity, 0.109 moles per liter. I've got my colors all messed up. My liters canceled out, leaving me with 1.09 times 10 to the minus 3 moles of thujone molecules. So what does that mean? So that means that if I have this big beaker of water that was a solution of thujone, so there's little thujone molecules floating around in here, and I poured some of this solution out into, say, a flask, and the total volume that I put in this flask was 10.0 mils, then in that 10.0 mils, I would have 1.09 times 10 to the minus 3 moles worth of thujone molecules. So that's what we just calculated. So let's do another example. Let's say in this example, I want 2 grams of thujone molecules. That's what I'm trying to isolate from my solution that I've made. So I want to know, if I want 2 grams of thujone molecules, what volume of our 0.109 molar solution do I need to get those 2 grams of molecules? So again, let's write this pictorially. Here's this solution that I have, and it has a concentration of 0.109 moles per liter. And I want to take some of this solution out and put it in another container. And in this container, I want there to be 2.0 grams of thujone. So I need to know what volume do I need to transfer to end up with this mass of thujone. Well, we know when we're working with molarity and volumes that we are never dealing with units of mass. So the first thing to do would be to convert those units of mass to moles. So if we did that, we would say we want 2.0 grams of thujone, and for every 152.23 grams of thujone we have a mole's worth of those molecules. And my units of grams cancel out. So you could do that calculation, or you could and write down how many moles and then do the next step separately, or you could just keep going. I'm just going to keep going because I now know how many moles of thujone I have if I've got 2 grams. I need to know, though, what volume of that 0.109 molar solution do I need to get that amount. So I know that I will need 1 liter of that solution for every 0.109 moles that I want. So now my moles cancel out, and this will tell me how many liters of solution. So if you do that calculation, you get 0.121 liters. So what this means is that if I take 0.121 liters of this 0.109 mole per liter solution and I transfer it to a separate container, I will have a total amount of 2 grams of my thujone solute. Let's do one more sample calculation. So in this particular example, let's say I want to make 100 milliliters of a 2.00 molar thujone solution. How many grams of thujone do I need to weigh out? Okay, so if I'm going to make 100 mils, that's the volume, of a 2.0 molar solution, I need to know how many grams of thujone do I need to weigh out. So you could think of this a lot of different ways. So we know that the moles of thujone per liter that we want is 2.00. And we also know that the volume we have in particular is 100 mils. So we can plug that in down here. We have, if we convert it to liters first, so 0.100 liters, that's our volume. We want to know how many moles then, X moles of thujone divided by the volume, which is 0.1 liters, gives us 2 moles per liter. So we could solve this particular equation for X, and that will tell us how many moles of thujone we need, and then we can multiply it by the molar mass, and that will tell us how many grams. Also do this all in one step. So I could say, I could take the volume that I'm trying to make, 0.100 liters, and I'm trying to make a 2.00 mole per liter solution. If I do that calculation, that tells me how many moles of thujone I need. But I need to weigh it out in lab, so I know that for every 1 mole that I need to weigh out 152.23 grams. Now my moles cancels out, and if I do that math, I know that I would need to weigh out 30.4 grams of thujone. And when I dissolved it in my 100 milliliters of water, I would end up with my 2.0 0.00 moles per liter or 2 molar solution of thujone.